Very well. I'm going to talk about hypothesis testing for the mean. So, hypothesis testing, HT, for the population mean. Let's change the focus so everyone can see. Okay, perfect. Population mean is denoted by mu. When we're talking about hypothesis testing for the population mean, we are dealing with two different cases. Well, we are having a hypothesis, an educated guess about the population mean or mu. As a statistician, you're going to wait a little bit, read the question, and check to see if the standard deviation of population is given or not. So in the next step, you're going to check to see if sigma or population standard deviation is given or not. Sigma is given. If it is given, we're going to follow some steps. If not, we're going to use another step to form and check the hypothesis test for the population mean. So the very first scenario is when sigma is given. The second scenario, sigma is not given or it's not known. Let's talk about the case that sigma is given to us. Then we're going to move on and talk about the case that sigma or population standard deviation is missing. So remember that sigma is population standard deviation. Okay. When it comes to sigma is given and dealing with hypothesis testing for the mean mu, we have three scenarios. The very first scenario is when you have a two-tailed graph. The null hypothesis says mean is k. The alternative hypothesis says mean is not k. In this case, we have a two-tailed graph. The graph is two-tailed. It means that the area for the p-value is divided up into two little areas to the left, to the right. A half of p-value is on the left, a half of p-value is on the right. This is your very first scenario, very first case. The second case, the second scenario is the null hypothesis says mu is larger than or equals to k. Its opposite, its complement says mu is less than k. In this case, we get a left-tailed graph. So if I ask you to graph it, you're going to say that, hey, this little area is going to be on the left-hand side, and this is my p-value. And finally, if your null hypothesis says mu is less than equals to k, its opposite, its complement says mu is larger than k. Mu is larger than k, it means that you have a right-tailed graph. Right-tailed graph. Okay, very well. The p-value or the probability is on the right-hand side. In the next step, we're going to find z. Z, or the standardized test statistic, is x bar minus mu divided by sigma over square root of n. That can be written as x bar minus mu divided by sigma times square root of n. Using z, you can find the value for p. So we use z to find the p value. To find the p value using our calculator. Then in the next step, you're going to check to see. Now check if p value is less than equals to alpha, the level of significance, then we reject the null hypothesis. Otherwise, we say that we fail to reject the null hypothesis. Again, this is the case that sigma is given. You're going to find your z value, standardized test statistic, and then find the p value, check to see if p value is less than equals to alpha, then decide about your null alternative hypothesis. Okay, now the most important case is when sigma is not given to us. We're going to follow the same step, but instead of calculating z, we're going to calculate t. That's the difference between them. Again, if sigma is not given, we are dealing with three different scenarios. The very first scenario is the same process as before. H naught, mu is k, our guess, our hypothesis, mu is not equal to k. So in this case, we get a two-tailed graph. It means that our p-value is divided into two equal portions to the left and to the right. A half p times a half p. So if you add these together, it's going to be equal to p. The p-value is the sum of these two little areas. Well, the second scenario is when mu is larger than equals to k. H naught, mu is larger than or equal to k, so its complement is mu is less than k, all right? So in this case, since we have less than, you get a left-tailed graph. Okay, left-tailed graph, it means that this p-value, the probability, is going to be on the left-hand side. This is my p-value. And finally, the last case, the last scenario, is when null hypothesis says mu is less than equals to k, and alternative hypothesis is mu larger than k. So larger than, it means that we get a right-tailed graph, the same as before. The scenarios, the cases are the same as what you saw before, right? There you go. This is our p to the right-hand side. There we go. So in your next step, instead of calculating z, when sigma is given, you're going to calculate z. When sigma is not given, you're going to calculate t. Your standardized test statistic is x bar minus mean, now divided by s over square root of n, or x bar minus the mean divided by s times square root of n. Well, now we're going to use t instead of z to find the p values. We use t to find the p-value. Exactly the same as what we did before. Here we have check if your p-value, this area, is less than equals to alpha or not. If it is, then we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. So hypothesis testing for population mean or mu and sigma is called the population standard deviation. We are dividing up this into two categories, two different cases. We saw this case before. Sigma is given to us, all right? Now we are introducing hypothesis testing for population mean when sigma is not given. Previously, when sigma was given, we divide up the null and alternative hypothesis into 1, 2, 3 different scenarios. To each scenario, we associate one graph. In the first scenario, if mean is equal to k, its complement, the alternative hypothesis, says mean is not equal to k. It means that we have a two-tailed graph, a half of p on the left, a half of p on the right. However, if it's the second case, the second scenario, if your null hypothesis says mean is larger than or equals to k, its complement says mean is less than k. Well, when mean is less than k, the area, the p-value is on the left, less than left side. And finally, if your null hypothesis says mean is less than equals to k, alternative hypothesis, its complement says mean is larger than k. Larger than k on the right-hand side. We get a right-tailed graph. So at the beginning, we check to see if sigma is given, then we write the appropriate null and alternative hypothesis for that question. In the next step, we need to calculate z value. Z is the standardized test statistic. X bar minus mean divided by sigma over square root of n, or x bar minus mean divided by sigma times square root of n. Now, after calculating z, we use z to find the p-value, these little areas, using z. Then check to see if this little area that you calculated is less than equals to alpha or not. Alpha is a level of significance. If it is, if this area, if this probability is less than this area, then you reject the null hypothesis. Otherwise, we say that, hey, we fail to reject the null hypothesis. Again, this is the case when you have sigma given to you. The standard deviation of population is known. In many scenarios, sigma is missing. In many real-life projects, you do not have sigma or the population standard deviation. Instead, you have a sample and you can calculate the sample standard deviation. In the very first step, we need to form the null alternative hypothesis and recognize the graph associated to that null and alternative hypothesis. Then, after doing that, you're going to use t, which is x bar minus mean, divided by s over square root of n, or x bar minus mean, divided by s times square root of n. S is the sample standard deviation. Why we calculate that? because it helps us to find the p-value, these little areas. After finding p-value, if p-value is less than or equals to alpha, we reject the null hypothesis, the same as before. If not, we say that we fail to reject the null hypothesis. We're going to take a look at one example to practice a little bit and feel more comfortable about what's going on in hypothesis testing. Perfect. We're going to talk about the mean lifespan of batteries. Okay, that's an interesting case. Imagine that a company sells portable walkie-talkie radios to construction crews. The batteries for these radios last for an average of 55 hours. So this is an important piece of information. The purchasing manager for this company receives a brochure in the mail that advertises a new brand of batteries. This new brand of batteries is cheaper than the brand that the company currently uses. However, the purchasing manager is concerned that the cheaper batteries may have a shorter average battery life than the current brand. Note, the number of hours that the batteries last is called their battery life. The pricing manager wants to perform a statistical test at 1% level of significance to determine whether the cheaper batteries have a shorter average battery life or not. So let us start. To write the null and alternative hypothesis, we need to look for the keyword. Okay, so what's the keyword here? When it comes to keywords, you need to look for the claim. So, the new brand of batteries. It's cheaper than the brand that the company currently uses, but the purchasing manager is concerned that the cheaper batteries may have a shorter average battery life. So, shorter, less than, all right? So let us take a look at our board and construct the null and alternative hypothesis. Step by step, we're going to build each one of these and try to analyze the null and alternative hypothesis that we have. Very good. Remember that. Identify the keyword. The keyword is shorter than or less than. It means less than. Meaning less than. The mathematical notation for less than, shorter than is this. So which case is this? Is it the first one? Of course not. The first one says equal to, not equal to. The second one says larger than or equal to, less than. Guys, we found the case that you're looking for. This is our case. Since we found the keyword in the question, we can easily identify the null and alternative hypothesis. So the null hypothesis says mean is larger than equals to, alternative mean is less than. Less than what? Take a look at this. Less than, shorter than the average battery lifespan of that the current brand. The current brand lasts for 55 hours. Okay, so larger than equals to 55, less than 55. Very good. So far, we constructed the null and alternative hypothesis using the keyword and identifying which case is this. The graph is going to be a left-hand graph, right? A left-hand graph. It's going to be fixed. So it means that my p-value is going to be on the left-hand side. This is my p-value. Very good. Okay. So let's take a look at the question. Well, in the next step, they're going to collect some data. To test his hypothesis, the pricing manager installs 40 randomly selected batteries of the new brand in the company's walkie-talkie radios. He finds that the mean lifetime of this sample is 52 hours with standard deviation of 10 hours. 40, the sample size. 52 is the average of this sample, and 10 is the standard deviation of the sample. So we collected the sample. We found the following. N is equal to 40 x bar, the sample mean is 52, and S, the standard deviation, is 10 hours. Well, we have all the information that we want to construct our T. Very good. So we can construct T. Construct and calculate T, which is equal to x bar minus the mean divided by S times square root of n. X bar is 52. The manager calculated the x bar for us, minus mean 55 divided by S, sample standard deviation, which is 10, times square root of n, which is 40. What is T approximately? So it says T is approximately negative 1.90. Negative 1.90. Okay. We said, hey, we calculated T because we can use T to find our p-value. So I have my T. My T is negative 1.90. Now I want to find this little area. Very good. So to find this area, we can use the T table. All right. Let us take a look at our T table and try to find. Very good. Let's take a look at this website. It says random variable t-score. The degrees of freedom, it's 40 minus 1, which is 39. The t-score that we calculated is negative 1.90, and we need the probability of t is less than equals to t. So let's see, you have about 3%. All right. So the area that is given to us is 3%. So let's take a look at our board. We use T to find the p-value. P-value, or the area to the left-hand side of negative 1.90, is about 3%, or 0.03. We found the p-value, which is about 3%, everybody. 3%. Well, now check if p-value is less than equals to alpha or not. Well, I found the p-value. P-value is 3%. 3% is, of course, larger than alpha, which is given in the question as a 1%. So what is our conclusion? We fail to reject the null hypothesis. So we fail to reject the null hypothesis. What's the meaning of that? Unofficially, we fail to reject. It means that we support the null hypothesis. So we support the hypothesis that the mean of the population is larger than or equals to 55 hours. So we support that mean is larger than or equals to 55 hours. This is our conclusion.